we are going to start module 2, and in module 2 we have topic or the process 3D printing processes basically related to wet polymerization processes. Okay, wet polymerization process. Okay, so in module 2 we will be talking about wet polymerization processes. Okay, so we already know, since we have studied the classification, we already know that there are basically three types of 3D printing processes, like solid based, liquid based, and powder based processes. Okay, and out of these processes there were basically uh, uh, these three out of these three category, we could see there were number of processes, and if we list these processes, the total number of processes is 7. Like first is your wet polymerization, then material extrusion, then material jetting, sheet lamination, powder bed, binder jetting, and directed energy deposition. So we will be talking about these processes one by one, and since our today's discussion, or our whole discussion in the module 2 will be focused on wet polymerization processes. So let me read it. What is wet polymerization process? In wet polymerization process, we can say it is a 3D printing process in which we have photosensitive material that are exposed to radiation, light, or you can say light, in a controlled manner to obtain a polymerized solid material. Okay, so what basically we are doing in wet polymerization processes, we have a vat of liquid. Vat means you can say a container of liquid resin. Okay, in which this complete container is filled with liquid resin, and you selectively solidify the this liquid polymer. Okay, by using your UV light. Okay, or 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 the light source. Okay, so this way, because since this liquid resin due to the polymerization, when it comes uh, in the presence of light or UV light, it get solidified. Okay, so the process is called polymerization. That is why the name is wet polymerization process. Okay, so other processes I will not be discussing today. We will take one by one. Okay, so among these wet polymerization processes, the limitation is that the liquid or the material must polymerize when it is exposed to light. Okay, so the limitation is that we cannot use this process to all kind of material. The property of material, it should be that the material should polymerize, or the liquid material should get solidified when it is exposed to light. Okay, so this is the main limitation, and there are different type of processes that have been developed in this in this category. And today when I was going through one of the paper, I found that earlier I was knowing only two, stereolithography and digital light processing, but when I was going through recent papers, I came to know actually there are four categories or four types of wet polymerization processes. Okay, so the first category is your stereolithography. This is the uh, first type of technique, or the technology that have been developed in the category of wet polymerization process. Okay, then we have digital light processing, then two photon polymerization, then volumetric 3D printing. Okay, so we will discuss these wet polymerization processes or the techniques one by one. Let us take the first case, that is the stereolithography. Okay, so before explaining to the through the slide, I have one small video. I got one very good video. So first I will show the video, then I will explain the rest of the slide, so that you get more clear picture about this process. Okay, so let me play that video. Where is it? Yes.
The Form 1 Plus is a stereolithography 3D printer Today, we're going to take a look at how it works and put it to the test against parts from an extrusion-based machine. Let's start by taking a closer look at the printer. When we open up the light-blocking cover, we can see a build platform inside. This metal plate is where the parts are made. Underneath the build platform is a resin tank. This clear window gives the ultraviolet laser a path to cure the resin. To start a print, we'll upload a file and fill up the resin tank to the indicator line. You can see the laser passing back and forth inside, hardening the liquid plastic. We'll take our printout and wash it in rubbing alcohol to get the excess resin off. The flower comes with supports on it, and we'll snip them off to finish the piece. Stereolithography is known for producing extreme detail with layers down to 4 times finer than a human hair. The Form 1 Plus lets us take advantage of a library of materials, so we made some other parts to show what these resins can do. A castable resin gives jewelers and engineers an inexpensive way to produce metal parts. This flexible resin is great for simulating different textures, and as we can see, this tough resin can really take a hit. Now let's compare how the Form 1 Plus parts stand up against a filament printer. The stereolithography part comes out nice and smooth, but we can see and feel the ridges on the cup printed with filament. When we break this sample piece, you can see that filament parts quickly snap along the layer lines. The SLA process creates a chemical bond, so our prints take much more force. Today, we took a look at how stereolithography printers work, the types of resins they can print with, and what makes the parts stand out against other desktop machines. If you liked our intro to stereolithography,
Okay, so I hope you get some visualization about this stereolithography process. Okay, so as you came to know, this is the oldest oldest type of your 3D printing process. Okay, and which was developed around 1980s. Okay, and in this we have a photo curable liquid. We have you can say liquid resin, and we use UV laser to solidify these liquids. Okay, in a controlled manner. Okay, so stereolithography, in short, it is written as SLA. SLA is a process which is based on the principle of hardening or curing a liquid photopolymer using a directed laser beam to solidify polymer into a specific shape. Okay, and these specific shape, basically the shape is determined by the your CAD geometry or the geometry whatever CAD model you have prepared in your modeling software. The containing a mechanism whereby a platform can be lowered or raised. Okay, so there are basically 2 types of processes. One may have you may you may fill the your photopolymer in the container, and as soon as your first layer is solidified, you are lowering your container by the layer thickness. And in some cases, in the another case, you may have process where after the solidification you are raising the container height by the height of your layer thickness. So both these processes we will be discussing in the next few slides. Okay. The liquid, talking about the liquid is a mixture of your acrylic monomer. Okay, so acrylic means these monomers are transparent. Oligomer, these are polymer intermediates, and a photoinitiator. When the platform is at its highest position, the layer of liquid above it is shallow. It means you have very a thin layer of liquid resin over this build platform, and since you are having very thin layer of liquid, if you move the laser on this particular source, okay, or sorry, on this particular liquid layer, ultimately it will be converted into solid form due to the polymerization of liquid resin. Okay, so as soon as you move the laser or ultraviolet beam is focused on the elected surface of your photopolymer, then moved in xy direction, ultimately it is getting solidified, or you can say the beam is curing the portion of your or the area wherever it is moving on the photopolymer. The platform is then lowered. We are talking about the mechanism where we are lowering your platform as soon as you are able to. Let me show the figure here. Okay, so here you can see you are having a build platform. It is your build platform. This is your you can say you have kept a base plate, and at this height, since your layer height of your liquid resin is very low, if you move your laser beam on this or ultraviolet beam on this liquid resin, what will happen? Due to the polymerization, this liquid resin will get solidified. Okay, and as soon as it is solidified, what you need to do? Again, you have to lower the build platform by the distance or the height equal to delta z or equal to your layer height. Okay, if you lower this height, again fresh layer of your liquid resin will come on this previously printed solid layer, and you will keep solidifying as soon as you will move the laser beam on this second layer, you will get the solid part. Okay, the process is repeated until you get your final product. Okay, so here, yes, we were here. Platform is then lowered sufficiently to cover the cured polymer, and the sequence is repeated. The process is repeated until level B is reached. It means you get your final product. Generate a cylindrical part with a constant wall thickness. The platform is now lowered by a vertical distance AB. Okay, so at level P, the XY movement of the beam are wider. A flange-shaped portion that is being produced. The process is repeated, producing another cylindrical section between B and C. Okay, so yes. So what we were focusing here, actually we are producing, or we are solidifying the liquid resin layer by layer. Okay, so this is your starting starting structure, and here you can see some portion of your product has been printed, and here you can see this is again liquid resin is there in the remaining portion of your wet, okay, or the container. So because your why there is liquid resin in the rest of the part, because you are controlling the movement of your UV laser source. So this way you are getting your you are solidifying your part or the liquid resin layer by layer in order to get your final geometry. Okay, so here you can see the same skeleton sketch has been redrawn again here, and you get your final product. Okay, so this slide basically A and P, it is talking about the this right hand side diagram. Here you can see first A platform is built, then B is built, then C is built by the controlled movement of your UV laser. Okay, yes. Here you can see one example, one sample part that has been printed using your SLA process. Okay, talking more about SLA process, how this SLA process works. So like the other processes, other 3D printing process, we have common things that we have to create the CAD model. Then we need to design the support structure for the part which is needs to be printed, if there is any support required or not, like some portion may require support, like here you can see, since this since there are some overhanging portion, these portion may require support structure. So we need to design these support structure too. Then convert the CAD model and the support structure into STL file. Then you need to slice your STL file. This slicing layer height may be 25 to 500 micrometer. Like 500 micrometer means 0.5 millimeter. Okay, so it may range from 0.5 micrometer to 500 micrometer. Yeah. So here you can see this support structure has been designed for this particular component, and it has been printed using your SLA process. Okay. Yeah. Yeah. So yes. So as after creation of STL your slicing data, or the creation of your slice data, what you are doing, you are first thing is that you will spread your liquid resin on your build platform, or you need to lower the build platform by the height equal to your layer thickness, or the print or the layer height. Okay, so as soon as you lower your build platform, the fresh liquid resin comes on this build platform, and after this, what you are doing, you are moving your laser on this particular thin liquid of resin, and due to the polymerization, it is getting solidified, and you are getting your layer is being created. And this process is repeated until you get your final product, or all the layers has been solidified by the UV laser. Okay, so by this you get your final product, or the 3D printed product using your SLA process, which may require after the creation of your 3D printed or the printing of your component on SLA machine. This process, this product is taken out, and it is taken away for further post processing, like it may require further machining, or some we may need to remove the support structures, like these ultimately these support structure are the unwanted material, so we have to remove it at a later stage, which is called post processing. Okay. Yes. So talking about the principle of SLA, I hope it is quite clear that in SLA process, what we are doing, we are building the physical models from the liquid photosensitive polymers, and how these are being created. Liquid polymer is solidified after the exposure, after its exposure to UV light along the scan path, or the controlled path of your UV light. Yeah. Okay. So this is one example of one layer, how this layer is getting solidified. Suppose we are having a thin liquid resin spread over your build platform, and how it is getting solidified. First, it is creating a periphery of your layer. Then here you can see the movement of your UV laser in between this controlled area. Okay, so first it is deciding the outer periphery, then you can see square boxes, or the movement of your UV laser in this particular bounded area. Okay, so this way it is actually solidifying your whole whole layer of liquid resin. And as soon as this liquid resin is solidified, the process is repeated for the next layer. Okay, so this way, yes. So this is how your SLA process works. And in SLA, we were talking about that we have two kind of arrangement. In one arrangement, we have to lower the build platform. Like in the second case, we are lowering the build platform. And there may be another case also where your UV source is kept below this transparent build platform. And what you are doing, you are exposing your your uh, your liquid resin below this build platform. Okay, so in this case, what we have to do, in this case we have to raise the build platform in the upward direction. Okay, but here in this case we have to lower the build platform in the downward direction. So there are two kind of arrangement. One is called upright style and another is called inverse configuration. Okay, so this is for today, because we have come to know that